for that last question, due to COVID-19 and a smaller class size, we weren't really able to get a lot of replicates in terms of analyzing each plate. Only 2 students analyze each plate each week. So that's only 2 sets of observations. And because of that, the data was incredibly inconsistent. Species identification was, no, it's a fairly hard thing to do anyways, especially when you can't actually like, look closely at the species and you're just doing it through a photograph. So one thing I did with this project was just research on the MIMIC program with the state of Massachusetts, which is Marine Invasive Monitoring Collective, and saw what protocols they used in order to better understand how we could do this better in terms of a class project. And so just having more replicates, more observations, and also utilizing software, well, not software, but apps such as iNaturalist and other community citizen science apps that exist out there to better substantiate our data. Seemed like could be a way to improve the quality of the data. However, despite the inconsistency of identification, I was able to find some interesting patterns and relationships between the different species. One most immediate thing to stuck out to me, which you can see in my figures, is that the invasive brown algae really like took off in growth those first couple weeks, but then significantly dropped as we headed deeper into fall, deeper into October. Meanwhile, kind of the opposite pattern was seen with the native species, which makes me think that, which leads to the question of, is there a relationship between seasonal variation in terms of the species abundance? Is that what we were seeing, or is there something else going on? I also was able to observe an interesting relationship between lacy crust bryozoan, brown algae, and green algae, dead man's fingers, where there's already an established relationship between the lacy crust bryozoan and the green algae, where the lacy crust will come in, kind of latch itself onto existing eelgrass, native eelgrass, kind of decimate the community, and then this other algae comes in to kind of colonize it. However, I noticed on plates that had the brown algae, that relationship wasn't happening. And it's hard to draw conclusions from that because of the inconsistency of the data, but those are just interesting patterns that emerge. Ideally, this type of observation and this type of monitoring is being done on a larger scale by the state of Massachusetts, but will continue to be done on an even broader scale to really understand like how these communities are structured and how these organisms interact. That way we have a better understanding of how to restore the ecosystems that have been lost through decades and centuries of industrialization and development. I know like key habitats such as eelgrass habitats, oyster reefs, those are what we want for rebuilding. But we can't do that unless we understand how these biofouling communities, how these existing invasive and native species are really living together. So feel free to check out my poster. I'm happy to answer more questions, explain more. Thank you.
Awesome. Thank you very much, Elise. Our next speaker is Ava Madden, Microplastics on Nantucket.
Yeah, it says I published it, but it doesn't appear published, so I'm just gonna share my screen, if that's okay. So I'm looking at microplastic risk on Nantucket Island and doing sort of a risk assessment. And so I'm basing it off the EPA's therefore step process of planning and scoping, and then phase 1 problem formation, and then analysis and risk characterization. And so the first straight up on the upper left, it's just sort of like the cycle of microplastics, and which basically microplastics are just small pieces, less than about 0.4 millimeters, and they come from majorly from non-point sources, and just it's a breakdown of larger just macroplastics pieces, just breaking into smaller pieces, and then sort of trying to figure out the risk of how this is going to affect the different unique ecosystems and species on Nantucket. And so it's really important to understand the source of where these are coming from. And a lot of the source, if in the middle part, I wrote about a little bit about like the septic system in Nantucket and about how there's certain mandates for sewer connections and things like that, because that can have a big impact on the wastewater and sort of introducing, as the wastewater acts as a point source of solution in a way. And then the middle picture is just different types and sizes of microplastics. Well, these ones aren't that tiny, but different. They show different sizes and shapes, but research still needs to be done on the specific different types of plastic because they're likely, I mean, they may have a different type of effect on organisms. And because the fish right here on the bottom right, it shows the different, the different parts of the animal and how different heavy metals and different parts from plastic can contaminate it. So a lot of research still needs to be done, but I'm trying to sort of piece it together and figure out the risk for the ecosystems of Nantucket.
Awesome. Thank you so much. And Ava, the only suggestion I might have is to save it, close out, and then re-enter and then submit again.
Okay.
It should work, hopefully.
Okay. Yeah. I was trying to I was scared to, but okay. Yeah.
Make sure you save it. And then if you go back, so there seems like there's some kind of glitch, go back in and publish, and hopefully it'll show up so that way you can interact in the room.
Yeah, I tried doing that a few times, but yeah, I'll do it.
Okay. And if you have further problems, just email me and we'll try to figure something out.
Okay, thank you.
Okay, thanks. And our last e-lightning talk of session 3 is Courtney, going back to Boston Harbor.
Hello. Okay, thanks. I'm actually going to do a little very mini PowerPoint because I kind of think in PowerPoint these days. So let me just share my screen. Okay. Okay. This is sharing some of the research I'm doing as part of my dissertation on that looks at tensions between climate change adaptation and shoreline regulation in Boston. As we know, global sea levels could rise up to several feet this century, which poses a grave threat to coastal cities, including Boston. So the city of Boston has been proposing building various shoreline protective features, flood protection features. And a lot of these would involve raising existing land or existing structures, but some of them might involve building out into the water, particularly features that are nature-based solutions like living shorelines or constructed wetlands. But currently, doing any kind of building or development or fill in intertidal areas is heavily restricted by current regulations. So my research questions have been, how do laws, policies, and permitting processes shape or constrain climate adaptation in Boston? How do various waterfront stakeholders view the use of intertidal fill for climate adaptation? And what are some of the key arguments and debates that could guide future policy discussions about this? And I found an overall consensus that that there does need to be some regulatory reform to allow for more fill for climate adaptation. But the restrictions on fill are complex and multi-layered. And there's no single path to doing some kind of reform. And a lot of the restrictions are also guided by discretionary permitting decisions by regulators. So there is some inherent flexibility in the system. And I know this is a 2-minute talk and I have a lot of takeaway points and findings in my poster. So I hope you'll visit my poster. One thing I'll just mention here is that we need to think about how to resolve potential conflicts between the way that we currently protect natural resources on the shoreline and climate adaptation. And the way that we do that might look differently in heavily urbanized areas versus non-urban areas. And that's it. So I'll see you all there.
Thank you so much, Courtney. So now is the time until 4:15 to go over to the iPosters gallery. Go to session 3, click on the posters and do the live chat to talk to the speakers. And we will be back here at 4:30 for session 4. So enjoy session 3 and we'll see you back here at 4:30 for session 4.